Energy. There are multiple different kinds of energy. You have kinetic, potential, you have light, you have heat, thermal, nuclear. Today we are discussing all the different types of energy and how they work. First, let's start with kinetic and potential energy. Kinetic energy is the energy of motion. It is the energy that causes something to move. Potential energy is energy that has the potential to turn into kinetic energy or another type of energy. Like, if a rock was on the edge of a cliff, it is the potential energy to fall down and gain kinetic energy. According to the law of conservation of energy, in an isolated system, energy stays constant. Also, energy is neither created nor destroyed, but transformed. Now hold on with me for a second. This makes a lot of sense. Potential energy on a roller coaster can be transformed into kinetic, sound, and heat energy. So, it isn't as crazy as it sounds at first. Okay, let's move on to light. White light contains the full spectrum: red, orange, yellow, blue, indigo, violet. It is only broken up into those colors when it is passed through a prism. Light is an electromagnetic wave, which means it can travel without a medium. When you see an object with a certain color, that is because that object absorbs every other color in the full spectrum and reflects the color that you see. Let's say you have an apple. It is red. It is absorbing every other color: orange, yellow, green, blue, indigo, violet, but repelling or reflecting red, which hits your eye or whoever else is seeing it. Okay, so as we know, the only reason things have colors is because they absorb everything else besides that color, which they reflect. So, we have many things, many different colors, because that's what they reflect. Like, look, we have red, we have orange, we have yellow, we have green, we have blue. We have everything. We have purple. And I guess you can say black, white. But I'm getting ahead of myself. Let's continue on with the lesson. Okay, let's move on to chemical energy. Chemical energy is energy stored in the bonds of chemical compounds, atoms, and molecules. It is released in a chemical reaction, often producing heat as a byproduct. Chemical energy is used in things such as batteries, petroleum, and it is even used to make energy in gas. Like when a car is running out of gas, it is using chemical energy technically. Humans run on chemical energy also. Now, let's talk about mechanical energy. Mechanical energy is the sum of kinetic and potential energy. A mechanical wave is a wave that needs a medium to travel. That's why in space, no one can hear you scream, because space does not have a medium, or is not a medium. Electromagnetic waves can travel through space fine. If they couldn't, well then there wouldn't be a giant ball of burning helium and hydrogen in the sky that we can see right now. But we can't hear it, because sound is a mechanical wave, and a mechanical wave needs a medium to travel. Okay, now we're moving on to the electromagnetic spectrum, which is a range of radiation. All of them are electromagnetic waves. It starts with radio waves, then microwaves, then infrared radiation, then visible light, ultraviolet, X-rays, gamma rays. So the radio waves, microwaves, that end of the spectrum has a longer wavelength than, the X-rays and the gamma rays. All used for different things. Listening to the radio or making a phone call, that'd be radio waves. Watching that plate of cold spaghetti from yesterday night heat up, that'd be microwaves. Anything you see all the time, visible light. Because that's the only part of the spectrum that we, as humans, can see. Ultraviolet, well, that tan on your skin, sunlight, has ultraviolet waves in it. X-rays, yeah, that bone you broke in 2nd grade, you need an X-ray for that. It's also used to prevent hidden bombs from being on your next vacation to Hawaii. Gamma rays, used to kill cancer and to sterilize certain tools after each use. They are very dangerous, as their wavelength is very compact and not as long and calm as other waves. Okay, so now let's move on to heat and thermal energy. They're not the same thing. Let's test you on it. Which has more thermal energy? This match? Or this magical floating iceberg? The other kind of iceberg. Yeah, that was the right one. If you said this match, you'd be sadly mistaken. Now, yes, it is the iceberg. Now I can hear you being like, what? But yes, while the match might have a higher temperature, which measures heat, it has a lower thermal energy. Thermal energy is the motion of the molecules and atoms inside the object. Now, an iceberg is a much, much bigger item than this tiny little match. So there are many more molecules in the iceberg than this teensy tiny little thing. So now you know. Temperature is the measure of heat, which you can measure in Kelvin, Fahrenheit, Celsius. And thermal energy is the measure of movement of the molecules and atoms inside an object. Good? I think we're good. Now you know. The more you know. Thank you for watching my video. This video hopefully maybe taught you a little bit, even though it might not be the best video or the smoothest. But now you know, and knowing is growing. The more